Okay, this is not my usual setup, so no camera today, I guess, but that doesn't stop the coding. And the sound is probably super canned and awful, and I just have like 15 minutes. Anyway, I know this has been a bit of a busy week, and at least I wanted to kind of get my hands moving with stuff with the quantum circuit simulator project. We had gotten to the point where we were able to print a circuit like that. Now we have two ways to go, two next steps, two directions. One is we focus on the graphical interface, or the second option is we just focus on the actual calculations, which I think that this is what I prefer doing. Because essentially we need to think a little bit more, so even if it's not fully a lot of coding today, at least it's going to help us move forward. So what do we have? So we have gates, we have gate objects, we have a circuit object. The circuit object has a constructor that you give it a string, you parse the string, and then essentially what this does is it creates a circuit element, and the circuit element has then gates in there, right? So let me basically print a circuit element. The circuit. So if I do, and I hope the keystrokes are not too bad. I did a small test before, a recording step before starting, just to make sure that I wouldn't kill your ears. But circuit. Let's print circuit. Let's see what circuit has, because I forgot actually. Oh God. And I'm using an English keywords. So it actually has a circuit object, then it has basically, it's an array, and each array is, what is it? Is a column, or what is it? Yeah, exactly. This one has, really? Z, so that's the first column, and here we have, yeah, okay, identity, and age. Okay, so essentially you have, that's interesting, right? Because the other qubits are not there now anymore at all. Like if I look at the column 0, 1, 2, 3, column 3 has got, okay, but that's good. So it's got multiple elements, so they're still aligned. This means the 0 element is always going to be the 0 qubit, the qubit at the top. Because essentially when it comes to doing these calculations, right, so one way to do these, for those who are not familiar with quantum computing, essentially each gate is equivalent to it's got a matrix, right? But then when you have multiple qubits, essentially it's like you can, sort of an inefficient way to simulate this would be that for each column you just aggregate all the matrices, right? And so you, as if this would be like one big operation for all the 6 qubits, and then you do this for each column, and then you just do like a product of all these, and at the end you get a matrix at the end, which is basically your final state of all the qubits, which you can then sometimes, not always, split back to a single qubit state, and sometimes you can't, which in this case it means it's entangled, or that some qubits are entangled. I think, to be honest, I'm feeling a bit rusty about this, but I think this is maybe the first thing to do, to kind of just implement it like this. I know, I'm not so sure if that's not the same like the state vector simulator. Do you know how to implement a state vector simulator? Is these, right? So state vector simulator is just basically saying, so here you have the matrices, right? So define a state vector for a single qubit. So can you give me an example for 2 qubits? And that's why it becomes, that's why it's inefficient to do these for higher number of, that's why it's impossible essentially for higher amount of qubits to do simulations. Just it becomes too complicated because the state grows too much. So if we do 2 qubits, the state vector of these 2 qubits, it's got 4 positions, so it grows exponentially. For those who are not familiar, if you're watching this channel, you're probably familiar, or if you are sort of someone who follows me, who's been subscribed for a longer time, then probably you're familiar with this. But if not, go check out the Quantum Computing 0 to 1 series. It's a very long series because it's over 300 hours, but it's me exploring all this stuff. So essentially, you define these, then you define the Hadamard, and then so that's how you entangle them. Essentially, so this dot product is what you're basically, it's like when you're advancing column by column, so to say, right? And I think that's what we're gonna do. So we're just gonna implement the state vector simulator. Now, I think what would be interesting is, and it will give us a bit of efficiency right off the bat, is maybe we should just have we should store, because there's not going to be a lot of columns, I'm assuming. It's just a toy simulator, so we can actually store a state vector for each column. That's not going to be a performance killer. The performance killer is the state vector size itself, so the amount of qubits. And to be honest, we should just limit the amount of qubits so don't kill the computer. The machine, like probably 6 qubits is already too much, actually. So we should really just kind of stick to a lower amount of qubits. 3 qubits is okay, or we can just do. Let's just do 2 qubits, because we can also just play with this with a very just simple example initially to test stuff. So no, but we can't, because I haven't implemented control mods. But let's just do something very simple, which is a Hadamard gate, and a Hadamard gate. So that will be it. So this is just 2 qubits, and I missed to close one of these guys. So this should just run to 2 qubits, and essentially the state. And we can do. You know what I mean? Because if we do it like this, then later on, if we change a portion of the circuit, we don't have to recompute it all. It just means that we can take the state vector of the previous column as a starting point and then evolve the system from there, right? So this would be cool. So let's do this, yeah. So essentially, I guess it's something that we can probably just do as we parse, right? And then it's a function that will be triggered every time someone drops a gate in the circuit. But then as we parse and then return a new gate, we need to have a function. That essentially what it does is, and it's a circuit function. It's like update state vector. Update state vector, something like this. So essentially, oh man, I'm like, what's wrong with the keyboard there? So update state vector. So what is it suggesting? State vector for each column, then get the gate, get the matrix. That's definitely not correct, the suggestion here. So, right, so the state vector would be something like I guess we need one for each column, right? So it's probably a similar thing like these. So I would actually just start here and say this is the state. So this is the column state, I would call it, maybe column states. And so what we're going to be doing is for each column, what we first need to do is we need to we need to do the Kronecker product. The Kronecker product is this part here. This is what you see here, right? So what the Kronecker product is doing is essentially making sure that you it's making sure that you compute like that you exactly that you essentially build up a matrix that can operate on all your qubits, because the Hadamard, like the Hadamard matrix, right? Which, by the way, actually I should probably use. I'm not sure if I should use NP array. It might be easy because then I can use all this Kronecker stuff. So I might as well just. So I'll ask. This is cool. So Ghostwriter, can you rewrite these by using NumPy arrays instead for the gates? So it does it well. Cool. So it actually it's even neater because it actually has a nice dictionary of gates, and then it's curious how different it is from what it originally suggested. Like, is it really just the way that I prompted it? Like, why is it defining it like this? And here we just have it like that. What is the difference? Because I'm no JavaScript expert. What does the def modifier do? But it's inside a class. So okay. In Python, but it's not. Oh, we're not in Python. No. Okay. That is why. Okay. NumPy. We're in JavaScript, bro. Oh God. So, is there a JavaScript to do matrix math like NumPy? Yeah, I guess just math. Okay, cool. So I'll need then let's do it this way. So parse JSON string. Then we'll just leave it like that. That's fine. It was a language confusion. Okay, so what we do is we do this. So what we need to do now is in a date state vector, for each column, the Kronecker, we need the Kronecker product of all the gates. So the Kronecker product of all the gates. So now, do I trust this shit? So what is it doing? So it's doing basically for each call, blah blah blah. It pushes everything into a gates, into the gates array. Form the Kronecker product of all gates in the column. Gates reduce. What is ACC? That's not defined at all. Oh no, sorry, that is just like it's a reduce and push. I have no idea what is column matrix. Interesting. Reduce. Let's test it out, and then from the Kronecker product of all the columns, return the state vector. No, but that's fine. I don't want these. I don't want the Kronecker product of all the columns. That's not what I want. I just want to push it in the column states. So I think this is the portion that I want. So I'm in LED gates. So. can give it a try, and I'll probably leave it here because I said I don't have much time. So with the gates, we do these, we form the product of all the gates, and then what we want to see is essentially update state vector. It's not column states, but this is basically its column states. So now I need to call this function. Parsing. Okay, so we've done parsing. I'm sick of all the need or not need for colons or semicolons. Jesus Christ, cannot people just make up their minds? I don't know. Makes me nervous. It bothers me. But if it works, it works. Okay, so this update state vector. Numeric is not defined. Where's numeric? Numeric. So import numeric. So you can import the numeric library by adding the following line to the top of the script.js. Shouldn't I just? Yeah, I cannot use an import statement outside a module. That's what I thought. Can I import numeric? Or can we do it without there a cron method math? Can I import numeric as a standalone script? I haven't thought of it. Yeah, exactly. Okay, we can try this. Is it gonna work? Let's see. Because I still have to fix all the other stuff, people. I know this. Script.js. Go to the bottom. Work. No, it's not defined yet. Is this at all something that exists, or is it a hallucinated? No, actually. I think someone's calling me. Yeah, that was a sound. This seems to be okay. Do I need to define all this? I don't care. I don't care. I don't care. I don't care. Okay. Get error that numeric cron is not a function. I don't want to import it like this. I'm not ready for this yet. This doesn't actually have a cron function, so do I have a cron function? Exist? Cron in math, you're fucking kidding me. Oh God, boy, you failed me. It seems like there is. So, I mean, is this the math that we know of? Math cron? Well, that's another math. Is this the math that like... Okay, so let me just not import this at all. Script, and I'll just try math. This math of cron. Okay, so that's another math. So, this is the best. I don't. So library. So essentially, use. No. What do we want? What do we want? So there another library to that offers a method. Okay, so this is math.js. That's the one that I just checked. There's NumPy.js. You kidding me? Okay. Let's do this. Okay. Cool. So I'll take that. Okay, that's interesting. So can you rewrite? Okay, so can you rewrite these using NumPy.js, using NumPy.js? So you get the stuff. So actually, let me copy all these. If that doesn't work, I have to leave. I have to stop. But let's see. So at least we figure out a mechanism to do this. Sorry, I didn't mean to save. And now we need these guys of date state vectors. So what it does is so this is gonna work. This is gonna break, and J is not defined. J is not defined. JS. It's maybe num.js. There's something like this. Do I really have to open this file? So oh, that doesn't exist at all. Okay, so NumPy.js. So it looks like this version doesn't exist. That seems to be a problem. It doesn't seem to get the specific. What if I remove the version tag? It's still gonna still a valid link. That's not valid. JS 0.16.1. Okay, so what if we just do 0.16.1? Is this a valid file? But this seems to work. Oh, original file. JS. Doubt this is it, is it? Ghostwriter. Seems the JS link you gave me is not working. Let's try this one. Is this even needed? It's even needed. That also doesn't work, obviously. Let me just get rid of these. And does this work? Also doesn't work. Num.js, hosted. NumPy.js, come on. I just need like a GitHub. The one these okay on the browser. There you go. That's what I need. That's what I need. That's what I need. That's what I need. Hopefully that's gonna work. Yes, that works. Yeah, that is actually the one thing. It's difficult to find, to trust the oh god. It's difficult to find something, or Ghostwriter is not perfect at these. Yeah. Well, now it's probably NJ. Yeah. Anyway, time's up. Sucks, but I think that's the. Oh, come on, 3 more minutes. 3 more minutes. Let's do 3 more minutes, okay? Let's do 3 more minutes. We can do this. We can do this. That's probably Num.js, how to use Num.js. So, and then how to use it. It says NJ. NJ should be fine. Array creation, NJ array. So, but I think I might have to adapt that a bit more. NJ is fine. But is there like a cron method? JS cron. Python. Cron. Yes, ask cron. Basics. Installation Num.js. It's something else. Num.js. It's the same. Installation. Usage. Guys, I have to find something else then. Oops, sorry. Anyway, sadly didn't make it yet, but I think that's the idea, right? So I need to find a way to do the Chronicle product with the right library. We'll get onto this in the next video. And then essentially I have the state vector for each column. Well, that's also not true, right? That's not correct. Column. This will be the column matrices actually. Column matrices this would be actually. And then to calculate the column state, still need to do here by multiplying the column matrices. Yeah, but that's like the next to do exactly. Yeah. States of these column keyboard. What's wrong with you guys? Oh. Anyway, cool, perfect. Sorry. Okay, cool. Then we'll leave here. See you next time with the proper setup.